Hi guys, welcome to this video on this particular question about areas of sectors, and this is taken from the review exercise number 2 from the textbook of Edexcel Pure 2. And so let's dive right in because this is a really good question, and it says that we've got a square ABCD with a side length R and two arcs of circles with centers A and B. And we need to show that the area of the shaded region is r squared over 6, in brackets 3, root 3 minus pi. So when you look at this question at first, you're like, okay, we can split this potentially up into, somewhere from the middle, okay? And because it's symmetry, we will be able to work this out quite easily. And that's my aim. My aim is to work out the area of this one region over here, and then just double it up, all right? So let's focus on working this region out. Now, if I split this up into, say, a sector, so I'm going to just draw this out in a few different colors. So let's say you have this point E, and if I just work out the area of this sector, okay, and then if I take that area away from this particular area, this small section over here, I would end up getting my required region. So let's write this down, okay, very clearly. So I am going to take away the area of the sector AD, and then take away the area of that blue section, okay? I'm just going to highlight in blue because it's a unusual shape. Okay, so I can work out the area of that sector ADE quite easily, okay? But how do I get the area of that blue section? So that blue section is also actually rather straightforward, okay? So if I consider the sector ABE, so this sector basically, right here, okay, and if I then consider the area of the triangle ABE, so the area of the sector, okay, the area of sector ABE minus the area of the triangle ABE, okay, so that will help me get my blue section, okay? So let's work that out. And for that, we would need the angles, okay? Remember that the area of the sector is given to you by half theta r squared, and the area of a triangle, when it's a non-right angle triangle, we always consider half AB sine C, okay? So we need those angles B, okay, right there. And that's pretty straightforward, okay? Because this is an equilateral triangle, because if I just draw this as R, this is also R, okay, because A and B are the centers of circles. That means that triangle AB is an equilateral triangle, okay, and an equilateral triangle, the angles are all 60 degrees. But be careful, we're dealing in radians, so 60 degrees is essentially pi over 3, okay, so 60 degrees is pi over 3 radians, and let's work this out in terms of r. We don't have to work out the value of r as the question doesn't ask us to. So for this, now the area of the sector is going to be half theta, which is pi over 3 r squared, minus the area of the triangle, which is half r squared, which is a and b, they're both equal, times by sine of pi over 3. So this will simplify to pi over 6 r squared minus sine pi over 3 is simply root 3 over 2. Okay, so root 3 over 2, like so, will basically give me root 3 over 4 r squared. Okay, so this is my area of the blue section, which we will now be able to incorporate into into our final equation. Okay, so let's put this here. So we need to work out the area of the sector ADE, and for that we need that angle DAE. Okay, so if I again just use another color, this particular angle in yellow is basically the one that we need, and that's quite easy. That's just going to be pi over 2 minus pi over 3. In other words, it will give me pi over 6. And so pi over 6, so if I work this out now, it will be half times pi, the theta, which is pi over 6 r squared, minus the area of the blue section. So that was just what I worked out. So I am gonna put that down here in brackets, and my next step will be to expand the brackets. So I'm gonna have pi over 12 r squared minus pi over 6 r squared plus root 3 over 4 r squared. Now in the equation required for the area that I need, I have to have a 6 outside, but that's for the entire area. Okay, so I'm gonna simplify this, of course. Okay, and this will just give me minus pi over 12 r squared plus root 3 over 4 r squared. And then from here, I'm gonna simply work out the factor which is common. So I can say that r squared over 12 is common, and then I'm gonna see what's left. So I'm gonna be left with a minus pi, and then plus, because I've taken a 12th out, I'm gonna have to have a 3 root 3 inside the brackets. Okay, so that's my brackets sorted, and it looks exactly the same as the brackets over here in my final answer. So now to get the overall equation, I just have to double it, okay, due to symmetry. So the required area therefore is going to be r squared over 6, okay, because it's going to be 2r squared over 12, which is r squared over 6. And there you have it. You have your final equation of the area of the shaded region. And I hope you found this useful. This was indeed a really good question. Let me know in the comments below if you have any questions. And once again, thank you ever so much for listening.